Hello and welcome to this InflectraCon 2023 virtual bonus session. InflectraCon will be held from April 19th through the 21st in Washington, D.C. on the campus of Gallaudet University. We are looking forward to 3 days of customer training, partner meetings, industry sessions, networking, and more. Check us out at www.inflectracon.com. In this session, we hear from Bradley Baird, Engineering Manager in Quality at NICE CX1. Let's join Bradley now as he leads his virtual bonus session entitled, Agile is Evil.
Hello, and welcome to InflectraCon 2023. My name is Bradley Baird, and today I'm going to talk to you about Agile. We've heard a lot about Agile. We've been using it for many years now. But I want to talk about it specifically from a particular viewpoint. And that viewpoint today is quality engineering. And my thesis is that Agile is evil, especially from the viewpoint of quality engineering. So in this session, we're going to talk together about quality engineering and Agile. And do they work together, or can they work together? So first, let's look a little bit at the history of Agile. Then I'll explain why I believe that Agile is evil. And then, do we need Agile in quality engineering, or can we still do things as we always have? And how does quality engineering and Agile, how does it differ from other methods? And then I want to talk a little bit about what are the hallmarks of being Agile in quality engineering. So that may give you a little bit of a clue as to where we're going to end up towards the end of this. So let's discuss quality engineering in an Agile world. First off, let's talk a little bit about the definition of Agile. Agile means that you have the ability to move quickly and easily. The method that was mostly used previous to the introduction of Agile was the waterfall method, which everyone knew was very slow and cumbersome, and it wasn't very easily adaptable to changing situations. Hence, the reason Agile was developed. But why Agile, right? So let's talk a little bit about that. And before we can answer the question about why, we really need to understand what Agile is and is not. So let's go back in time a little bit, get a better understanding of why Agile was created in the first place. So let's move back to the 60s and 70s, where IBM dominated the software development world, or better said, the hardware world, because back in that time period, it was all about the hardware and not the software. The software was just starting to come into its own. And what happened then, the development was very slow. It was cumbersome. It created or needed a lot of time to do this. The popular programming languages in those days, specifically COBOL, required flowcharting and excessive planning before you ever wrote a single line of code. And the result of that was it could be months after you actually started before you actually wrote any code whatsoever, during which time requirements easily could have changed. But then we had the 1980s, the PCs were introduced. At the beginning of the 1980s, there were only about 1 million PCs around worldwide, and that number had grown to over 300 million by year 2K. You can see that marked increase in computers also resulted in a very marked increase in demand for software. People wanted to use these computers for a lot of different purposes. So we needed software, and we needed it quickly. The introduction of this cheap, plentiful hardware required that people were quicker We couldn't take 8, 10, 12, 24, 36 months to release a piece of software. So there needed to be a better way of doing things. And that better way basically was Agile. And so let's go back to the very beginning and see where Agile started and why. So it was way back on February 11th, 2001 in Utah at the Lodges Snowbird Ski Resort. There were 17 people that met and they started talking. And the result of their conversation was what we know today as the Manifesto for Agile Software Development. So the question I have for you right now is, have any of you actually read the manifesto? Do you really understand what it says and what it means? Let's take a look at it. It's very short, it's not very long. And this is it right here. There is a better way of doing things. At least that was the resulting conversation that happened. And this is what they came up with, where it was more important to have good processes. So here it is, the Manifesto for Agile Software Development. It reads in part that we're uncovering better ways of developing software by doing it and helping others to do it. Through this work, we have come to value individuals in their interactions over processes, working software over documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So, what they essentially did is they found the most cumbersome and difficult parts of software development and devised new methods to treat and to react to those particular conditions. And this is what they decided that they wanted to do. The ending or the complete version of this is that they say that there are value in these items on the right. I mean, after all, this is the way that software had been developed now for 40 years, 40 plus years, almost 50 years. But in the end, they decided that the things on the left were what was really important. And those are the things that we should strive for. Hence the reason for the Agile Manifesto. And so after I read this manifesto and I did some research, I concluded that in reality, Agile is evil, especially with regards to quality engineering. Now, you may say, really? But you just told us it was a good thing. Well, it was a good thing for software development, but let's take a little bit deeper dive into who were these people? Who were the evil scientists, as I'd like to call them, that met together on that fateful weekend up in Snowbird? And here they are. They came from all different aspects of programming. There are lots of different programming methods by this time, as we can see here. But these methods continued to look for, I mean, these guys were all looking for a better way of doing things. That's why they came up with all these different methods for programming. But if we really look carefully at who these people really were, and so here they are, these are the manifesto authors. And so were they really programmers? Did they really have programming at heart? Was that really the interest that they had? Or was there maybe an underlying motive for what they did? And if we look to see what these people actually did in real life, it's kind of interesting that they all have a very common background, and that is they were all authors. These people, they made their living not by writing code at this point in their careers, but by writing books about writing code. And they needed something else to write about. They needed another way to make money. And They all started with a development background with one lone holdout, which was Brian Merrick. And we're going to talk a little bit about him a little more a little later. And so after I read this, I discovered, or I came up with what I think are 5 problems with Agile. And they are basically, by its nature, Agile is for developers who are experienced, notice that word, and that they know what they're doing. Not only that, it assumes that everyone is an expert in the field, and it assumes that a skill set for an agile team is the same as that needed for a non-agile team. And the mistake that is often made is that teams can start in agile um, without any experience whatsoever. And my 5th problem that I want to talk about is that new and unproven team members should not be put into an agile team. So these are the 5 things that I identified and why I say that agile is evil. And let's see if I can prove or defend my thesis here. So first off, the whole point behind agile was to make code faster and better. Is it really doing that though? So let's take a look at 2001. Agile was introduced, and there were about 18 errors per 1,000 lines of code. Let's fast forward a few years, right? Now we're up to 20 to 30 bugs per 1,000 lines of code. But again, Agile is brand new, right? We're still learning it. It hasn't really gotten wide adoption, but it is starting to be picked up. And so, it just seems a little bit natural that maybe the bug count would go up a little bit or the error count would slightly increase. And here we are now, 9 years later, and notice that, hey, look, maybe something good is happening because the errors per 1,000 lines of code is actually going down. By this time, Agile has been very widely adopted. Hundreds of thousands of programmers are using it. And it looks like at first glance that maybe this is really working and it's doing and it's having its intended purpose. But let's scoot forward just a few years and notice that suddenly, oh, we seem to be trending in the wrong direction. The errors per 1,000 lines of code is not going down anymore, but now it's starting to go back up again. And here we are 12 years later after the introduction of Agile. But what about just a few years ago? As of 2020, look at that number. It jumped all the way up to 70 bugs per 1,000 lines of code. Definitely not the trend that we're looking for or we're expecting. And why is that? Why did this happen? Well, let's talk a little bit more and maybe we can understand and come to a conclusion of to why our lines of code or the bugs per lines of code is going up instead of going down like we would expect it to. Especially in this day with the modern IDEs that we use that pretty much do a lot of coding for us. They have the autocomplete, they look up things for us, they have integrated pretty much everything. The life of a developer today is so much quicker, easier, and better than it was, at least from a coding standpoint. But apparently, none of those improvements have actually made us better coders as far as eliminating defects. So, from the point of view of a quality engineer, why is it that Agile is evil? Well, here's my first assertion that Agile software was designed for developers, by developers. It was not created to optimize quality assurance. And we saw that in those numbers as the code got progressively worse and worse over the years. My next assertion is that if you want to truly be successful in Agile, you must have a solid foundation in the fundamentals. And this is the reason why I think that we're seeing our code getting worse and not better as Agile continues its journey. As we get farther and farther away from the beginnings of Agiles, we're ending up with a whole different group of people who are doing the programming than what we're doing the program 20 years ago. So let's take a look at this and see if we can understand it. I want to first look at some lessons from the old masters. These were very, very famous painters. You may recognize their pictures here, but let's talk about each one of them very, very quickly. First, Van Gogh, his Starry, Starry Night picture. Um, One of the most famous in the world, again, highly acclaimed, and people were amazed at how he was able to do this, right? But before he painted this picture, right, which really seems to contravene pretty much anything that artists were doing at the time, um, he painted this picture. And this picture, if you look at it, you'll notice many, many of the fundamentals and basics of art that are incorporated into it, from his color palette to his vanishing point on the horizon to the way everything is laid out, his rule of thirds and fourths that he's taken into account. If you understand art and you look at this painting, you will realize all of the rules that were followed in order to make this picture what it is. Let's take another example, one from Salvador Dali. Um, with this painting, again, groundbreaking, changed the rules, everything was different. But before he was able to paint that painting, he painted this painting. And this one, again, if you understand art, you understand the basics and the fundamentals that were used to create this picture, how the lighting was used, how he tried for the realistic effects and the textures and just the essence behind this painting, what he was trying to accomplish. All of this is based on the fundamentals of art and good design practices. Now, here's our last example from the great masters. Again, the water lilies, Claude Monet's probably most famous painting ever. Um, Most people look at it and they understand what the painting is, but they realize that, right, that this is impressionist, right? This is not something that is absolute and concrete. But again, before he was able to paint this, he painted this. And if you look at this, you realize that there's a big difference between these two landscape paintings, where this one is very realistic, uses all of the different techniques that artists used at the day to make a scene that looked almost like a photograph. Again, very, very different in the approach. But again, the point I'm trying to make here is that before these artists were able to create these seminal pieces, these masterpieces that are world famous and highly, highly acclaimed, they didn't start by painting those pictures. They started by painting these other pictures, which were basic, which followed the rules, which followed the studies, the everything that everyone had learned about how do you create art. They incorporated all of these things, the basics, the fundamentals, into their training before they went, shall we say, a little bit different or became agile in their approach to what they were trying to accomplish. Because each one of these paintings definitely have those agile qualities versus the fundamental basic qualities to them. Let's look at one more example, not this time from the old artists, but in the construction industry, right? We're all familiar with construction and how it works, especially road construction. So, traditional construction techniques. Here's a picture of a road that's in California. This particular section of road was 1 mile long, It was 4 lanes wide, had no bridges on it, which are considered one of the more difficult and expensive pieces and time-consuming pieces of road construction. They literally spent 15 years planning this rebuild of this one section of road. And then they spent 5 years actually rebuilding the road, which really is astounding, but that was very, very common for the time. Now, if we take agile techniques and principles and put those into play, here's a different example. Now, here we have a freeway that is being constructed. It was 24 miles of freeway construction. It was 10 lanes wide. It had 63 bridges. They only spent 2 years in the planning stage for this road and 3 years constructing it. And so, from these examples, we can see that agile principles really do pay off. I mean, they are good. They can do some really good things. But the problem is that all of these things were done by people who understood the fundamentals. They were done by people who had learned their craft, that were basically already experts in it. Let's look just a little bit at the hallmarks of what it means to be agile, right? If you're agile, you're using sprints, you have backlogs, you have grooming, planning, retrospectives, you have program managers, project managers, product owners, etc. Right? You're not driven by the desires and the whims of the development teams, but rather you're driven by the market, right? Your developers are working from a backlog. Um, the objectives of your sprints are clearly defined. You've got user stories in place. And once your sprint starts, you don't add any new work to it. At least you're not supposed to in the agile world, right? Sometimes it does happen. But the other important thing is that the end of the sprint, you have something that's ready to release. Now, these are the hallmarks of what Agile was all about, right? They took the waterfall method, which again could take anywhere from a year to 3 years to develop a piece of software that could be released that a user could actually use. And they took that and shrank it way down to where you were releasing at least a piece of this software at the end of every sprint. And your sprint could be 2 weeks long, 3 weeks long, 4 weeks long. The industry is kind of standardized on either a 2 or 3 week sprint. And so, right, instead of a customer waiting now for months and months and months, they're able to get something in just a couple of weeks, usually, which which is really good. And so the developers who devised this system, the developers who invented Agile, really came up with a great system for developing and getting software done quicker. But again, remember the premises, the problems that we have with Agile, and that Agile is evil. So, how do we take Agile that is evil and turn that into something that's good, right? Because our release cycles are shortened. We have more buggy code statistically. And so how do the people on the QA side or the quality engineering side, how do they adapt? How do they incorporate agile principles into their work so that they can take advantage of these new things that are going on? Well, one option that we have, and let's talk about very quickly, is this concept of exploratory testing. Now, you probably are familiar with that already. It's a method that's used in waterfall techniques as well, but it's really more suited for agile methodologies because we want the testers to find important bugs fast, right? In agile and in testing in general, right, you're never going to find everything, and in fact that's unrealistic. Everyone knows that, but the goal is to find the most important things as fast as possible, and that's where exploratory testing comes in. And so kind of like with the Agile principles in exploratory testing, we don't have long drawn out processes and documentation. We are looking for ways to do things quicker and faster. But then how do we measure this progress though, right? And how do we know what's been covered? And how do we manage this process? These are things that make things a little bit different. And this is how we also modify slightly the exploratory testing for Agile and move into this system that's called session-based exploratory testing. And in session-based exploratory testing, we have a way to measure and manage this thing because we break the testing down into sessions and we give each session its own charter. And then as we're working through that charter, we document all the details. We document what areas have been covered, how much time, the defects that we filed, etc. Right? We then take all of these session files and summarize them, put them together into a document to create the reports. And we send these reports out and help people to find the information that's necessary much quicker, much faster, and much easier. So, again, this is one way of adopting an agile type of an approach into quality engineering, right? If session-based exploratory testing sounds something, like something you'd like to learn more about, here's a few links for you that you can look at that will help you understand in detail how to do that. Okay, so let's move forward now to Brian Marek. Remember, I mentioned him. He was one of the original manifesto authors. He was the only one there that had a QA background. And so it kind of stands to reason that he would kind of come up with a QA methodology or a QE methodology to use in Agile. And this is what he did. This is the framework that he came up with in order to be able to move the QE engineering, quality engineering part into the Agile world. And so we start in these four different quadrants that we have. Support or business facing, and where we critique or technology. And he put these different kinds of testing in each one of these quadrants, where we have acceptance testing, where right, which is business facing and programmatic, right? And so we build the right code. We write tests before the coding is done by developers. We define what it means to be done, and so on. So if we look at this other option right here, right, we have TDD, or test-driven development, which is a method of where you start by writing the tests instead of writing the code. And so you write the test and then you code to the test. And so that's one method or one way to help and bring this in. And then we have our functional testing, which is kind of the backbone of a lot of the testing efforts, right? And we focus on the user stories, and we look to see what's missing. We do a lot of analysis, or what they call static testing, to investigate where problems may occur before we actually even have to push a button or launch a product. And then finally, we have this last technique that he came up with, which is called parafunctional testing, which involves basically system testing, bringing everything together, and doing these performance and scalability testings and operability. So this is a framework that can be used to help you understand how you can move your quality engineering aspects into the world of Agile. So let's take a look then really quickly about quality engineering in an Agile environment, right? So how is it the same in Agile versus waterfall method? Well, you still have to test everything, and you still need to make sure that all the requirements are met, right? And ultimately, you still have to release a product. But how is it different, right? What is the big difference in QE and Agile? Well, first off, the traditional role of a manual versus an automation tester goes away. In Agile, you are neither a manual tester nor an automation tester. You're a quality engineer, and you can't um, you can't really specialize. And we'll talk about that in just a second. And the question is, but why, right? Why is there this difference in these roles? And the biggest reason why that in Agile, teams are small and they're not designed the same, right? You don't have huge groups of people that are working on a project. You have these small teams that work together that are tasks with doing things quickly and efficiently. And so, because generally of staffing constraints and budgetary reasons, you usually don't have the luxury of having lots of people that specialize in only one area. You have to understand how to do everything. You have to have a very solid foundation. You have to be able to do lots of things quickly. Basically, you are a jack of all trades because we don't have the time or the space or the money for a specialist in a true agile environment. So, what does this mean really then for quality engineering? Um, it means that you have to be experienced, not necessarily specialized. I mean, you can be, but you have to have experience everywhere, right? You have to have an advanced understanding of your product and how it's supposed to work. It means that you have to keep pace with development efforts. It means that you start your quality engineering tasks before the code is actually written. And it means that you finish your sprint at the same time that development does. And it means that you release at the end of a sprint. I mean, that's always a constant with the way that Agile works, is to have that releasable code at the end, right? It means that you have to be fast. It means that you have to adapt. And it means that you have to change as needed. It also means that, dare I say it, you have to be agile. You can't simply do business as usual and survive in an agile world. So, what are the takeaways that we have from today's discussion? Hopefully, I've given you a good understanding of why I felt, initially that agile was evil from a quality engineering standpoint, and educated you a little bit about what some of the pitfalls of agile can be and some of the methods that we can use to overcome those limitations. So, what's our first takeaway from this is experience is mandatory. You have to be experienced if you want to succeed in an agile world. And the numbers that I showed earlier about the lines of code or the errors per thousand lines of code kind of bear that out. Where in the early years of agile, the code was getting better. It really was. But as time went on, suddenly the code started to get worse and worse and worse. And it wasn't because the engineers were getting worse per se. It was because we had an influx of brand new people coming into the system, people who weren't used to the old system, people who didn't have a basic, solid understanding of the fundamentals of what it really takes to develop software properly. And so we need to be wise in what we do. We have to understand that there is education that has to take place. We need to educate our stakeholders as to what the advantages and disadvantages are in being agile. But also another thing that's really, really important to point out, and this kind of maybe will sound completely counterintuitive, but you don't have to do agile in your quality engineering department just because the devs are doing Agile in their development. Again, remember, Agile was not designed for quality engineering in mind. It was designed as a development system for writing code. And so we actually can divorce the two from each other, and you can have a non-agile QE department working with agile developers. And so understand that that is a possibility, and that is one way to overcome some of the problems and concerns that may be held. Um, but if you are going to do agile, then you need to adopt agile frameworks. You need to adopt the way that agile is doing things, and make sure that you have found ways um, to overcome some of the 5 disadvantages that agile introduced into our development network. um, and and then take heart, right? If you're not there yet, but that is where you want to be, then set a goal on how you're going to get there. Again, we don't start off at the very beginning knowing everything. So we need to learn. We need to take these things, take them one step at a time. Come up with a plan of how you want to make sure that your quality engineering efforts are going to match those efforts with the development efforts, and kind of fill in the gaps, and overcome the overlooking, per se. I don't know if that's really the way we want to talk about it, but we want to kind of fix some of these problems with agile, and we do that basically one step at a time by setting a goal to get there. And as we do that, as we work on these things, then obviously um, we can take agile, which has proven benefits, and we can turn it from being evil into something good, and something that is going to help us actually achieve and deliver not just software quickly, but quality software, which is what everybody's end goal really is. Well, thank you for your time today. I appreciate you spending a few minutes with me. Thanks for watching, and I wish you all the best.
Thanks for joining us for this virtual bonus session. We hope you enjoyed it. Learn more about InflectraCon, our live, in-person conference from April 19th through the 21st, 2023 in Washington, D.C. by visiting inflectracon.com. Stay tuned for more great content, news, and events from Inflectra. Learn more at inflectra.com/company.